Hi, this is Sung. I want to give you a super hard bonus question for the super keen, diligent, bright sparks out there that want to really ace Locus. All right, Locus type questions. Now listen, if you are doing extension 1, right? Yes, this super bonus question will be fairly extension worthy. Yes. But this will be a pretty standard question that you might come across in extension 1, right? So for extension 1 standards, it's not going to extend you all that much. But for the mathematics course, yeah, this one's a real extension type question. All right. So let's go through it. All right. So A is a point where the circle with equation x squared plus y squared equals to 16. So obviously it's a circle with center 0. Or with center the origin with radius 4, right? That's the equation of the circle. And A is a point where it cuts the x-axis, all right? So if it cuts the x-axis at, if this equation cuts the x-axis, we're dealing with this point here and that point there, okay? So you've actually got two values of A, right? Your first value of A is there, and your second value of A, let's call it A dash, is there. So A is equal to, let's call it 40, and your other value of A, let's call it A dash, is equal to negative 40. Got it? Because that's where it's going to cut the x-axis, all right? But they're both A. They're going to be A at different times, right? Then it says, find the locus of the midpoints of all chords of this circle that contain point A. Now, what is a chord, right? A chord essentially is a line that joins 2 points on the circumference of a circle, right? One of those points is going to be A or A dash. Your other point is going to be the point P, right? It's going to be your arbitrary locus point, all right? So let's do that. So let's give this point P a name. Let's call that P, X, Y. And what we're saying is that you've got that chord and we're finding the midpoint of that chord, right? And let's call that midpoint point M. And let's give the coordinates of that midpoint capital X and capital Y, right? So we're going to call that the midpoint of AP, all right, or A dash P. Got it? All right. So here's what we know, right? We know that A is equal to the point 40, A dash is equal to the point minus 40, point P is equal to the point XY in both cases, right? P is equal to XY in both cases, right? Let's work out the coordinates of point M. All right, so I'm going to come around this way. M for AP is going to be, and we use the midpoint formula here, and I should have actually written the midpoint formula. Silly of me to leave the midpoint formula out, because sometimes we will need to use the midpoint formula as well, like in this particular case. And when we use the midpoint formula, what we get is that the point for M is going to be X plus 4 on 2, and it's also going to be Y plus 0 on 2. Does that make sense? Okay, now the midpoint for A dash P, which is your other value of A, is going to be X minus 4 on 2 and Y plus 0 on 2. Got it? All right, now let's, we're going to do something sneaky here, all right? So, let's consider those two cases, right? I'm going to keep these two cases separate. Let's work out what point X is. X is going to be equal to X plus 4 on 2, and Y is going to be equal to Y on 2. Does that make sense? Right. Now, let's also do this so that we don't get confused here. I'm just gonna, all right, so it gives us some room to work. Let's work this out, right? In other words, what I'm going to do, and this is the sneaky bit, I'm going to take the x coordinate here, with a small x coordinate here, not the midpoint coordinate, but the small x coordinate, and make that the subject of the formula. All right, so let's do that. All right, so what we've got here is, to do that, we double both sides. So we've got 2 capital X is equal to x plus 4. All right, which means you've got 2 capital X minus 4 is equal to x. X is equal to 2 capital X minus 4. Got it? Your y coordinate is just going to be 2 capital Y equals to y. Y is equal to 2 capital Y. Got it? All right. So I'm going to just put a circle around that, and I'm going to just put a circle around that, because they're going to be very important to work out the locus of this particular question. All right. I'm also going to do this one here. All right. And that's, it's just a matter of set and forget. We're just going to basically apply the same process. Let's do that. You've got capital X is equal to x minus 4 on 2. Capital Y is equal to y on 2. 2 capital X is equal to x minus 4. 2 capital X plus 4 is equal to x. And we're going to swap it around just to make it look clean, pretty, and tidy. We're going to do the same thing here. 2 capital Y is going to be equal to y. All right. Now, well, let's kind of make it kind of look like this, so that you've got everything sitting on the right side of the equation. The right side being the left side. Yeah. Okay, cool. So the midpoint of the midpoint of AP is going to be given by this, right? The midpoint of A dash P is going to be given by this, right? Now, the point P, which is XY, is going to be given by this, right? Your relationship between P, the coordinates of P, and the coordinates of your midpoint are going to be given by this, right? Whereas where X and Y are the equations or the coordinates that satisfy this original equation. Does that make sense? These coordinates, the small x and the small y, if we substitute small x and small y into this equation, it will substitute and be true. Does that make sense? Because this small x and that small y are going to satisfy the equation of the circle. Got that? So we're going to use that property to do exactly that. We're going to substitute little x with 2 capital X minus 4, and we're going to substitute little y with 2y. That actually gives us, so let's do that, x squared plus y squared equals to 16. All of a sudden becomes 2 capital X minus 4 squared plus 2 capital Y all squared equals to 16. All right, do you see what we've done? All right, when we simplify that down, we can factorize 2 out, but that 2 that we factorize out has to be squared. So we factorize 2 squared out, which is 4, and that gives us x minus 2 all squared. If we factorize this 2 out, we've got to square it when we factorize it out. It becomes 4 outside of y squared, and that's equal to 16. Divide everything by 4, and we're left with x minus 2 all squared plus y squared equals to 4. Now, what is that equation? That equation really is a circle with center 2, 0, and radius, do you see that? With the square root of 4, which is 2. Does that make sense? Yeah. And we're going to do the same thing here. And isn't this a sneaky way of doing things? 2 capital X plus 4 all squared plus 2y, or 2 capital Y I should say, all squared equals to 16. And somewhere along the line I've basically interchanged the small y's and the big y's, and hopefully you weren't confused along the way. This should be big X and big Y. All right, and we'll do the same thing here. We're going to factorize the 2 out, which when squared becomes a 4. We're going to factorize a 2 out, which when squared again becomes 4, equals to 16. Let's divide everything by 4, and we've got X plus 2 squared plus Y squared equals to 4, right? Now, do you see how we started off with the relationship that we were given, right? And using other relationships which we were able to determine along the way, we worked out the equation of the locus of the midpoint, capital X, capital Y, right? And so this ends up being a circle with center -2, 0, and radius equal to 2, right? Cool. Now, if we were to graph that on our number plane here, right, the radius of the circle, or sorry, the equation of this circle would be another circle here, and the equation of this circle would be another circle here. So let me show you basically what's going on. So you've got, whoops, what we've got is another circle here, all right, and it will cover that point there, and another circle here. Now, it doesn't look like a circle, it kind of looks more like an egg shape, yeah, but it is a circle. So you've got one circle here, one circle here. Now, what I also want you to know is similar to some of the questions that we did in the past, this point here and that point there, your point A and your point A dash are not going to be part of your locus, right? So what we've got to do is we've got to show that there is a hole at that point. Got it? Okay. So in other words, excluding the point, what is it? 4, 0, and excluding the point -4, 0, okay? And it's gonna be this answer and that answer combined. So we're gonna use the word or rather than the answer, or rather than the word and, okay? It's gonna be the union of these two circles rather than the intersection of those two circles. Whereas this point here, it will be included. It's not a closed circle, it's a colored circle. Got it? Good. Okay, so that is a really sneaky question, but it's a question that might be asked, okay? So, yeah, so be prepared to answer those sort of locus type questions. In the next episode, what I want to cover, all right, is parabola, the parabola as a locus, right? And just as a bit of a taste, a foretaste before we launch into that, the locus of a parabola, even though as a function is a quadratic equation, as a locus, it'll be a moving point that will be equidistant from both a point and a line, okay? Great, fantastic. The other thing I wanted to mention is, yes, locus does also include regions, but I feel like I have covered regions sufficiently well, both in the equations and inequalities section, and also in the functions and relations section. So if you want to look more in depth at how to do regions, look into those chapters rather than this one here, okay? All right, thank you very much for watching. I'll look forward to seeing you on the next episode. Bye.